Okay, we've been looking at Pythagoras' theorem and triangles. We've got the standard notation, standard orientation, and we've got A and B and C. And we said that A squared plus B squared equals C squared. I'm going to talk about the angles, the sides at least, of this triangle here. There's my angle theta. You remember this one here is the complementary angle, which is 90 minus theta. There's my right angle. I've got my angle theta, and I'm going to fool around with theta. I'm going to make it bigger and smaller, so we're going to consider different shaped triangles. I'm going to call that O, and this one A, and this one H, and that's really, really important. O equals opposite. The reason I'm doing this rather than sticking with A and B and C is that this O here is opposite this angle. So what we're going to start doing is talking about angles and how they fit into right angled triangles. And to do that, I need to be able to distinguish. I can't just have A and B because I might be talking about this angle up here. And so I've got O, which is the opposite side. It's just a standard convention, really. This A is equal to adjacent, which means next to, which is this one here, because it's next to the angle, you see. And that H equals the hypotenuse. Hypotenuse. And I'm sure you remember that Pythagoras' theorem is that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So with this notation here, we know that H squared equals O squared plus A squared. Brilliant. Well, I'm happy with that. That's really great. This is, all it is just a notation, O for opposite, A for adjacent, and H for hypotenuse. And we'll just do it, rather than using A, B, and C, we're going to use O, A, and H. And if we do spherical trig, we need different notation again. So anyway, I'm going to stop there. Stop.